Okay, so the topic which I'm going to talk about today is another similar interface which we just saw in the previous presentation. So this device is called TapStrap 2, and it's a study done by some of my students. One of them is Motti, Kelbessa, Ryan Freas, Luke, and myself, Dr. Tauheed Khan Muhammad. This study would have been done at Augustana College in Illinois in USA. I was working last year over there, so these students worked with me in a class called Human-Computer Interaction. So they make a project, and this is what I'm going to present today. So let's talk about the introduction. So the introduction of TapStrap 2. So intro is basically it's a wearable keyboard and mouse combo for hands-free control of devices, and the weight of this device is approximately this is like 0.45 pounds. So it's I would say around 100 more than 100 grams, I would say. So it has a VR compatibility. It comes with it is compatible with Oculus Quest, which is now with Facebook. Facebook owns that product. It is also compatible with Oculus Rift, Oculus Go, HTC Vive, Microsoft HoloLens, and Magic Leap 1. It has a keyboard functionality that works. Basically, it has five 3-axis accelerometers, one for each finger, and it has IMU, which has 3-axis accelerometer plus gyrometer located on the thumb. And it also has a mouse functionality. So if you can see over here, this device is you see in the image. This is wearable device. It could be wear on your fingers, and based on that, we can take multiple decisions, and we can use as a keyboard. And this device is being compatible with, if you can see, it's been working with laptop, smart TV, smartphone, tablet, VR devices, projectors. The OS which is compatible with, it's pretty much with every renowned OS, Apple, Android, Windows, and Linux. It has a keyboard functionalities which I talk about. So it has unique characters are designed to each finger or finger tap combination for a standard keyboard functionality. For example, if somebody wants to make A or B or C or type of character, they can use different kind of combinations, and comes with 5 3-axis accelerometer, one for each finger, and it also has the IMU, which is a 3-axis accelerometer, and it is located on the thumb. Then it also has a mouse functionality. So if you can see over here, the top part which is showing 3 rings, this particular part, it has a sensor. If you rub that part onto the screen, onto the table or flat surface, this works as a mouse. So it's been enabled by optical mouse sensor located on the thumb. Right. Now, argument for TapStrap 2. So it's been the argument that has been made that it's going to replace the keyboard and mouse. This is the argument that have been made. Let's evaluate how accurate they are. This device is basically expensive than the normal keyboard and mice. So it's basically cost around, back then it was $200. It has a very strong, steep learning curve and discomfort when you wear for a longer periods. Sometimes the tap readings are unreliable. For example, if you are typing a alphabet P, it's sometimes recognized as Q. So there are some kind of unreliable tap readings. It's not been recommended for day-to-day work because it's have a long steep curve. It's not very comfortable. So this has some other usages, right? But it could be used for people who are hobbyists and creative people with custom software to extend the functionality. It could be used for Blender with some of the software come from Adobe. So this device could be used as a collaborator to these softwares. Some similar devices which have been available, one of them is called Azeron Cairo, which is basically an ergonomic gaming keyboard with unique design. It has both keypad and wrist adjustable and rearrangement. It has a concave keys for easier touch identification. It is paired with wrist rest for comfort during the gaming sessions. It also works either as wired or as a receiver-based device. The second one is Tap XR. It's again a wearable keyboard and mouse for VR and AR devices for virtual and augmented reality. Basically, it's a device that fits over your wrist and detects tap and swiping gestures, connect via Bluetooth, compatible with both VR and AR. It fits over your wrist and detect your taps, swipes, and for specific actions and functions. It can control devices through tapping of fingers, offer hand-free and intuitive interaction. The third device which we have explored is called Twiddler 3, which is one-handed coding keyboard for efficient text input. It's been advertised for computer programmers, gamers, and people with disabilities. It has compact, portable design, can be attached to a keyring for portability, and the Twiddler connects the device using Bluetooth. Right. Now, coming to the research part, so we are talking about our device strap 2. So research, the trajectory mapping analysis, what we are doing, we are studying and performing object movement over time. We are using some mathematical and statistical techniques for pattern recognition. The goal is to understand the patterns and trend in motion data and make projections or directions based on information obtained. So we try to make up this application used in different robotics and different devices. So this we are trying to observe the pattern. For example, somebody's trying to make C, how different way it could be making it makes. For example, somebody's trying to, let's say, move it around, what kind of gesture he's gonna make with this device. So we try to observe those patterns. Then we come with some kind of cool UI based thing, which is we are using some Python based GUI. For example, in Adobe, we can make changes to the image. For example, we click the picture from the cell phone, we can increase the brightness, increase the saturation. So we are trying to do by using this device. So for example, if I'm making a gesture, I can increase the hue, I can increase the saturation by using this device. So we are trying to create a cool utility for Adobe Lightroom, and we are using Python GUI, graphical user interface, for display our features, Python, and we are implementing by using tkinter. Then we also use a library called Pillow, which is from Python based again. It's a free open API that's been used for editing pictures. Through with this API, we can get features through which we can play around with isolating RGB channels. We can edit the blur and hue of an image, and then also we can change the RGB value of a picture. We can perform other features like resizing, rotating, and cropping of a picture. Then the issues with this device is basically it has some problem. That means it basically performance issues with we cannot dynamically edit the pictures in Pillow and displaying in GUI. Installation sometimes issue with PIL and Pillow, they could not be installed together. That's again problem. We are using two libraries simultaneously and learning how to interact. So we have used these two libraries and we learn, and then we have a time frame constraint that we are trying to fix it into a schedule of approximately 1 month. Now, the map which you are seeing on the screen right now, the right side is the software manager, which shows the settings. The left-hand side is basically are some key tabs. For example, the block dots on the left-hand side showing the first block saying that first finger, second finger, third finger, fourth finger, fifth finger. So what gesture we can make. Second is making two together, two fingers together, these two together, or maybe these two together. Then the third combination is maybe we can make alternate fingers together. For example, leaving the one finger. So we are trying to do using two fingers and leaving the one between. So these are different combinations that we are trying to observe and make patterns out of it. And then based on that, we can make a map to alphabet. Now, because this is this tool is very open and it has different development tools available. So it has obviously for iOS, Swift, Android, Java, we can use C#. It has a plugin for Unity, and it has open source Python programming tools available for making different applications. Right. Now, when we are implementing the TAP SDK input modes. What we are trying to understand, there are multiple modes through which we can collect the data. Text mode, controller mode, text and controller mode both together, and then raw data mode. This data mode, this is I have used this in the previous study, what we are trying to do to improve the accuracy. This gives you a raw numbers, like in a form of Excel sheet, and we can fit into a model, training model, into an algorithm for machine learning. And then based on that, for example, let's suppose if I tap A 200 times and I collect the data all the time, then I fed and train the model saying that this A looks like this based on this data. Then I click B 200 times and collect all the data. Similarly, I collect all the data for all the 200, like 26 alphabets, every alphabet having tapped 200 times. It gives you very voluminous data of like big Excel sheets. We collect them all the data and then fed them into an algorithm and train a model. And then based on that, take the decisions. For example, if something new gesture come to a computer, to this device, then it'll detect what kind of alphabet we are trying to evaluate now. Now, this particular device, it has different components. So if you can see over here, it has a button for connection and deconnection, that is power button, tap event, mouse event, air gesture event, raw data. So if you can see over here that perhaps it has on the top, the thumb ring, it has power button. It has also optical mouse, the mouse glider, then haptic feedback unit, removable stoppers, accelerometers, and then it adjustable TPU rings. This is basically for the skin safe. Then we write, this is just a little bit about the code which we write. So for example, if you have to write the table of what the issues which we face while implementing those devices, these are all the functions on the page right now, which talk about in main, we have different functions which we can invoke for controlling this step 2 by using Python code. So sometimes we have a problem which is called callback function, and we also face some issue having a curve of continuous looping. So we need it does not understand when to stop. So these are the issues which we have seen, but we observe when we implement this device comes out to be very accurate. We would able to control, like it's like the way we control the knob, the FM in our car, based on same knob, we can perform hue and brightness of our image by using this kind of gesture. We can just move our hand like this, and it will take it as that means we are moving the knob, and we can increase the hue or blur of an image. That's all from my side. I'm more than happy to take any questions regarding Step 2 and my work.